not put down this fact in the notes before because we got right to it. But everyone have this in the notes? This unicycle with sine, cosine, tangent? Okay, right below it. Don't change the page. Then start the next page because it's important and we're going to talk about it today anyway. Okay, so cosine of theta is what coordinate? No. What did we figure out yesterday? Cosine of theta equals x. So it's the what coordinate? Yep, is the x coordinate on the unicycle. What about sine theta? What was that on the unicycle? Yeah, is the y coordinate. Now, yesterday when we were doing tangent of theta, we were talking about opposite over adjacent. And Kennedy, we said that it was y over x. So given it was y over x, and sine of theta equals y, what can we replace with y in this example? So yesterday we were talking about sine, cosine, and tangent on this little triangle. And we said that sine of theta is opposite over hypotenuse. So that was y over 1. So it just equals 1. So sine theta equals 1. That's why it's the y coordinate. So tangent of theta was y over x. So if sine of theta equals y, instead of writing y, what can I also write? Y equals sine or cosine? Yep, sine theta. So instead of writing x, what can I also write for the bottom? Yeah, cosine. So cosine theta. So tangent, I can't hear you, Ronaldo, if you try to talk. So tangent of theta equals sine theta over cosine theta. We're going to use that to get that in the future, to get what tangent of theta is going to equal. Yeah. You wrote the rest of it in your notes yesterday. It's just this bottom part that we're adding, because we just didn't put it into words before you guys left. I'll give you a second to write it, because then we're going to move on to 5.2. Okay, thumbs up when you got it. Okay. Good. Okay. Okay, now you can flip your page and start a new page. Now we're going to move on to 7.2. Which is all about evaluating trig functions. And let's start with our unicycle. Let's draw one. I would definitely draw a big one, so if you need a washer, come up and grab it. Yep, to draw a circle, if you want one. Oh yeah, it's the closest I'm gonna get to a circle today. I could. Maybe I'll try that next. It's just so far. I don't like it. No, I changed it yesterday to something else. Okay, let's draw our triangle in there. Same way we did it yesterday. In quadrant 1, up above, it touches the circle at one point. We draw a radius. Bring it down to the x-axis, and then draw an x-axis. That is our triangle. Chetty, what type of triangle is this? Yes, it's a right triangle. What is its radius? Anybody? Radius is 1. 1. When you use a circle, always radius 1. And then my theta is down here, connecting to the x-axis. We call that a reference angle. Now, if I want to draw the same triangle in the different quadrants, how do you think we're going to draw it? Same triangle, but in the other quadrants. So like that? Yeah. Okay. Do you all think it's gonna be written like that? No? Okay, Sebastian, what do you think? What? Okay, I want you guys to extend this line all the way down. So we just drew a diameter. Yeah? Okay. Go straight up. Yeah? Okay. Now go through the center, draw another diameter. And then connect those triangles. Okay, that should be a straight line. Yep, that's what it's going to look like in all of these. And this is my reference circle. Reflecting over, like over here it's over the x-axis. This is over the x-axis. This is over the y-axis. Yep. So theta in all of these is called the reference angle. Is the reference angle. And is the acute angle formed between the terminal side and the x-axis. Now, that's kind of a lot of words to remember. We're going to write it the same way every single time. What type of shape does that kind of look like? Okay, kind of flipped over hourglass. Anyone else? Okay, you think about this really hard. Go more like Angel's thinking. Hourglass. What other shape does it look like? What? It, it so does. Yes. Mm-hmm. What else? I'm trying to see if you guys can get it. I don't think so.
Looks like a Power Ranger thing.
It looks like a bow tie.
Oh, okay.
Or a butterfly, if you think about the wings. So this is... What? I mean, I was just trying to think of the triangles inside. So this is bow tie and butterflies. So we draw it like so. Go ahead.
That is a me thing, just so you know. You're going to hear in pre-calc, I'm going to reference bow ties and butterflies like a billion times. This is always what I'm referencing. How you draw a triangle.
I kind of like the Ben 10 thing too, though. I didn't even think about that until I saw that. That's such a throwback, Kennedy.
I used to have
Mm-hmm. Did you watch the TV show or the movie?
the Ben 10, was it
Omnitrix? Yeah.
The watch.
See, I grew up on the TV show, and then the movie came out when Gwen had like powers and everything. Yeah, I like that. Mhm. They're supposed to come. What didn't they have a live action thing that was like really really bad,
There's always a bad live action movie.
right? Okay, in this quadrant, these are our points, right? X and Y points. Okay, if we're in quadrant one, okay, this is cosine. Actually, we'll pause on this for a second. We'll teach that at the end. Actually, I kind of want to do it now. Okay, this is a point. This is our x, y, right? If I want that and cosine and sine, which one would come first? X is what? X coordinate is cosine. Yep, cosine of theta. And our y is the, yes. Okay, is cosine positive or negative right now? Okay, is sine positive or negative? Okay, so if I had tangent, which is of theta, which is what over what? Sine over cosine, yep. Sine theta over cosine theta. So right now we have a positive number over positive number. Does that give me a positive or negative number? Yep, positive number. So we're all positive right now. In quadrant one, we are all positive. Okay, let's go over to quadrant two. Okay, is cosine positive or negative?
It's cosine to y then. Cosine is negative.
Yes, cosine is negative because cosine is x. Landon, is sine positive or negative over here? Yep. Okay, so tangent of theta is sine over cosine. Is it positive or negative? Negative. Great. Okay, let's go down below. Freddie, is cosine or x value negative or positive here? So I'm going in the x direction. Is this the positive or negative? Negative. Perfect. Yep. Okay, what about my y? So I'm going down, right? Negative. Yep. Okay, so tangent of theta, would that be positive or negative here? So I have a negative over a negative. Yep, it's positive. Okay, last one. Cosine positive or negative here? Yep, positive. Lily, what about sine? Okay, yep, negative. So tangent of theta would be what over what? Yep, negative over a positive, which makes it negative. Okay, we kind of have to remember what's positive and negative here. That's a lot to remember though, right? You want an easier way to remember it? Okay. This is an acronym, the island. Okay. In quadrant one, which ones are positive? Sine, cosine, tangent, which ones? All. Great. A for all. Quadrant two, which one is positive?
Sine.
Sine. Okay. S for sine. Quadrant three, which one is positive? Look back. Tangent. So A means all is positive. So A equals all positive. S equals sine of theta is positive. T means that tangent of theta is positive. The rest are all negative. Okay, what about quadrant 4? Yes, cosine. So here, C equals cosine of theta is positive. What? I have no clue. They make a lot of noise. Um, and I always go in a C direction. So you can remember this by all students take calculus. Yep. So you need to remember which one is positive. What? I told the pre-calc kids. Maybe. Yes. So if I said, where is sine negative and cosine positive, which quadrant am I in? 4. So cosine is positive here or here, and sine is only negative down here. Yep. Okay, so where is tangent positive but cosine negative? Where is tangent positive? Which two quadrants? Okay, 1 and 3. Which one is sine negative in? Yep, 3. So we're in quadrant 3. Yeah? Wait, last one. Where is sine positive but tangent negative? Show me with your hands. Where is sine positive but tangent is negative? Sine positive, tangent is negative. I'll wait till everyone has it. Don't just look at each other's. Okay, yes, it's 2. Quadrant 2. So sine is positive in both of these. Then we have to say which one is tangent negative in. Well, it's not A because it's all positive in A. So it has to be quadrant 2. Great, you just did part of pre-calc. Okay, let's go down. Do you want to do an example? Okay. Example. I'm going to tell you that pi fifth, that point is 0.81 comma 0.59 on a unit circle. I want you to tell me what is the sine, cosine, and tangent of 6 pi fifths. I will do the first half with you. The second half is your own. Okay, pi fifths. Where am I on my unit circle? What quadrant? Yes, 1. If we're not sure, get out your unit circle that you all had yesterday. So pi fifths is in between the pi 6 and the pi fourths. So we're right there. We're at roughly like 36 degrees right now. Yeah? Okay, so we're about right there. Ooh, that was bad. So that is my reference angle on this side. Where would 6 pi fifths be? What quadrant? Get your unit circle. What quadrant would it be in? This is pi 6, pi fifths. So now I want to see where is 6 pi fifths.
It would be in the middle.
It's going to be one of those two. 216? Okay, what quadrant would that be in? Quadrant 2 is 90 to 1. Yeah. Okay, so let's draw our bow tie. So we're drawing our bow tie right now. This is our bow tie. We're trying to figure out where 6 pi fifths is on our circle. We don't need it right now. We don't need a circle. Down here? pi fifths is up here. So if we look on our unit circle, pi 6 is about 30 degrees, and pi fourths is 45 degrees, and it's like right in the middle of those two. So it's in quadrant 1. Yeah? Or you can just change this to degrees. Kenny, you want to change it to degrees? Okay. I'll tell you right now, it's 36 degrees. Okay. So what quadrant is 6 pi fifths in? Yep, 3. So we're down here. So because we have our bow ties, we know it looks about right there. So that is our theta. Okay. So I'm in quadrant 3. Yeah, what's up, Michael? No, because we're going to do more of these, but I'm just in 6 pi fifths, so that's in quadrant 3. But it's always going to have this reference angle if I'm in quadrant 3. Yep, we'll do more in different quadrants. Okay, this point, I told you what it was. It was 0.81, 0.59. Okay, what is sine over here? Okay, yep, this is sine of theta. What about 0.81? What's that? Cosine of theta. And they're both positive and negative. Okay, so if I was down here at this point, what would be cosine of theta? Negative what? What was our cosine up here? Yep, so it's just negative 0.81.
I think it's supposed to be 8.
Yeah, it's an 8.
Where's the 1?
Because that's what I gave you. It's 0.81. Yep. Close parentheses. Okay. What about sine of theta? Brent. Oh, that's fine. Sebastian. Sine of theta. What is it going to be if we're down here? Yep, 0.59. How do I get tangent of theta here? Flip it. Yep. So it's sine theta over cosine theta. So Amy, what's on top? Yep, and the bottom? Yeah, great job. So is it going to be positive or negative, Amy? Yep, positive what? You might need calculators. Okay, I'll round it. 0.073. So it's the same values, except we're just changing if the positive or negative given what quadrant we're in. Do we need a brain break? Okay. What's 4? Bus driver? Okay. Do you guys like bus driver? Okay, I won the last round of bus driver, guys. I'm letting everyone know on the camera. This thing is even on.
2 rounds?
No, Amy won the first one. I won the second one. I think I won one of them yesterday. It's like the only game that's like really fast that we can play. Well, y'all sitting down now. So maybe at the end. Okay. Special. We're going to look at some special right triangles to evaluate trig functions. Special. Yeah, what are special right triangles? Geometry people, you should definitely know this. Okay, 45, 45, 90.
30, 60.
Yeah, those are two. Those are the two we're looking at. That's it. Yeah. Because the other one is a 30, 60, 90. Now, do we remember our triples?
Yeah.
Yeah? Okay, what are they?
50, 60.
No, what are our triples? No, it's about the sides of these triangles. How they relate.
Oh wait, yeah, I forgot. I didn't remember the side stuff.
Okay.
Oh wait. Where the 45, 45, 90? I know that. Okay. I remember like the sides. Like the sides would be the same. Like the legs would be the same except for the.
No, that would be for the iPhone.
Yeah, okay.
Yeah, the legs are the same. Right?
Let's draw it and see if you remember. Let's draw 45, 45, 90 in our unit circle. See if you remember. Maybe if we draw the circle. Yeah, but did you use a triple? No, no one used the triple.
No one?
One person used a triple.
Oh wait, I didn't use it because obviously. I knew that the two sides would.
Yeah, but you took longer to figure it out.
That was easy.
Okay, I drew about 45 degrees. 45 degrees right there. Now I'm going to go down over here. And, Chetty, same question. Same answer. What is the angle I just made right here? Yep, 90 degrees. So what is this last angle up here?
45.
Yep, 45. So we just made it 45, 45, 90. Now, angles and sides have a relationship. We're going back to geometry for a second. Because you guys don't remember your triples. Which sides are congruent in this shape? The sides, yep, sides opposite of the 45. So this one is congruent to that one. We're going to call this S and S. It's not a 5. It's an S. So S, S, those are two sides. Yep, and I won't make you guys figure out the third side. It's S times the square root of 2. S times square root of 2.
I didn't use it.
Okay, yes, it's ABC, but this is going to give us the lengths of these sides. So, I don't know. I think I did, yes. Mm-hmm.
But it was good to have.
Yes. So if I went from this side to this side, what do I have to do? I don't even like talking about that. Okay, what is the length of this side on the unit circle? We already know it. Okay, if I drew a line on a circle from the center out, what is that? If I had a circle and I went from the center to a point on the circle, what did I just draw? My radius, yes. And my radius in my unit circle is 1. So we know that S square root of 2 equals 1. S is this side length. It's the length of the short sides. We don't know that. We're going to figure it out though. Yeah? Let's figure it out right now. Sebastian, if I want to get S all by itself, what should I do in this equation? What's happening between S and the square root of 2? Okay, S, right now it's S times the square root of 2, right? If this was just a number, how would you, it's just a number. We're going to divide by the square root of 2 on both sides. All I'm trying to do is get S by itself.
Wait, is that
S. It's all S. There's no 5. It's all S. Every single S, every single 5 you think is there is an S.
Or
is that so that the pi?
Yes. Okay. Right now I have S equals 1 over the square root of 2. Now we're in algebra. We never put a square root in the bottom, right? No, we don't. We put it in the numerator. How do I put it in the numerator? Yep. What clever choice of 1, Mark. Wait, Mark. Yep, perfect. And what does that equal? What's in the bottom?
1, 2, 1.
Yes, it should just be 2. So, because the square root of 2 times square root of 2 is the same thing as square root of 4, because it's 2 times 2. What's the square root of 4?
2.
2. Yep. Okay, so 2 is our denominator. So we know that both sides of this triangle right here is square root of 2, 2. Yeah? Okay, I'm going to erase this for a second, just so I can write it. So then what is this point right here? So S equals what?
Oh,
1. Square root of 2 over 2.
Yep, square root of 2 over 2. Also equals square root of 2 over 2. So how far over on the x-axis did I go? From here to here. S is the length of this side. Yep. So how far did I move over? Yep, perfect. Square root of 2 over 2. How far up did I go? Yep, square root 2 over 2.
Oh.
So I'm going this way and I'm going up. So we just found a point. Right there. So S is the length of all these sides. Yep, so we found that S equals square root of 2 over 2. So that's the length of this side. So if I'm at 0 and I went up here, I'm going up my y-axis, how much? Yes. Boom. We just found a point. Yeah. I'm sorry. I'll switch. Yeah, it's the dark thing. Square root of 2 over 2. Square root of 2 over 2. Angel, if it ever happens, just remind me. Okay, let's draw our triangle in a different quadrant. What quadrant? Freddie, pick a quadrant. That's not 1. 3? Wait, Freddie's how you picked? Okay. No, Freddie picked 3. Okay, so let's draw it down here. So, do our bow ties and butterflies. Like that. So Freddie wants to go in quadrant 3. I'm going to pick a lighter color. So right here, this is 45 degrees. So, same thing we did before. Now we're in quadrant 3. What is my coordinate down below?
Negative square root of 2 over 2.
Yup. Yup. Great. Do you have any questions about how or why they're both negative? Yep. So it's all students take calculus, only tangent is positive down there. Everything else is negative. Yeah? Okay. Should we figure out what tangent is? So tangent of theta equals what? Okay, we're going to pause there. Yeah, we'll do that tomorrow. Actually, whatever. We'll do it now. Sine over cosine, right? Okay, so what is sine over here? Y. So then over 2 over 2.
Would that just be equal to 1?
We're doing the first one.
Yep.
Yeah.
Leanna got it.
Yeah.
What?
One's positive, one's negative, right?
Oh, well, over here right now. But, yeah, so positive. Over here we're both negative. Over here we're both positive. Tangent on all sides. Right now we're doing tangent of this side.
Would probably be like inquire what tangent. Okay.
Mm-hmm.
I get it.
Okay, do we know how Landon got 1?
Yeah.
Yep, okay, because it's the same thing on top of each other. Okay, get out your unit circle. We're putting this in our unit circle.
So the 45 is square root of 2 over 2.
Yeah.
Tangent the whole is tangent the whole circle?
No. I'll tell you in a second. It's, okay. I'll tell you in a second. We'll talk about it tomorrow because it's a long conversation. It's like the slope of the line. Because it's rise over 1. We'll talk about it tomorrow. Let's focus on, yes, which is also rise over 1. Okay. We're here. Landon, what degree are we at? Yep, 45. So we know that this is square root of 2 over 2. And square root of 2 over 2. And tangent, we're going to add tangent. Tangent of theta equals 1. Perfect. Okay. And then down below in third quadrant, so at 225, we also know it's negative square root of 2 over 2. Negative square root of 2 over 2. What would tangent be over here?
Negative 1. Actually,
Okay, remember, yep, all students take calculus. Tangent is going to be positive down below, so it's still 1. So tangent is 1. Okay, let's scooch up. 135. So we're still at, okay, yeah, negative 1. Okay, but is my first number positive or negative? Yeah, negative. Square root of 2 over 2. And then is the next one positive or negative? Positive, perfect.
Wait, the middle one over the middle one over the square root of 2.
Yep, always square root of 2 over 2, and then you just have to figure out it's positive or negative. So fourth quadrant, down below, what is my point? Square root of 2 over 2, yep. Yeah, square root of 2 over 2. And then what is tangent? Negative 1. Perfect. Sine, yeah. So sine of theta equals y, and cosine of theta equals x. And then tangent of theta, Sebastian, equals what? Yep, y over x. Yep, I'll be done there.
Wait,
Yeah.
so would all of these be the same thing?
No, no, because we're at 30 and 60, but we're gonna figure it out tomorrow.
It's gonna be like 3, 4.
No, it's like 1/2 is one of them, so that one's easy, and then a square root of 3 over 2. Yep. Okay, we'll talk about it tomorrow.